In this exercise, we're going to explore the possibilities for taking in information from maybe Site Surveyor, which is just two-dimensional, and we're going to look at how we can take that information, raise it into the third dimension, create a tin model from it, a 3D tin model, take sections through the site, re-level the site, carry out operations there, update sections, and even calculate the volume difference between the site we started with and the site we finish with. So we'll start off by just having a look at the site in 3 dimensions. So we'll go into a constrained orbit there, and we see that it is purely 2-dimensional. And if we get close in on there, we'll see that what we have are just a series of spot heights. Now these spot heights, if we look at our object properties here, so we see that they are just pieces of text. So if we wanted to maybe take that and the block reference, which is the marker position, so we could take the two of them. If we had more positions, we could simply copy those around and then edit the data that we have, so the spot heights. So just editing that, and we can change that to 0.99 for instance, and we could do that for whatever, adding in new pieces of text if we wanted to. So there's our site. We've added a couple more levels to it. We can simplify this drawing because it's as in common with many drawings that come in, whether it's from ProMap or surveyors. You'll find that it's layered, and here I've just simplified it by taking the 2D information. So we can have a look at what we have here. Just taking the spot heights and the markers, and going to our DTM application. So here we're in the DTM tools. We'll convert all of those points into the third dimension. So in other words, raise those points from the WCS that we have to put them in their rightful place in space. Now the way we're going to do that, you see we have different possibilities here, because there are occasions when information comes to you in different formats. Here we have a block reference as the marker with text. We could have block references with attributes there, or even just points and text. But we'll go with the block reference and text, which is what we have here. And you'll see that we can layer the information too. So we can make sure that we continue to keep our drawing nicely structured, so it's easy to edit in the future. We can dictate what colour the points are, the text distance there, maximum text distance, to limit the search area when Caddie is actually working out all of these points. So that can speed the whole process up, and we can do that with a pick as well. And here we have our drawing units and height units. So if we go with our drawing units and our height units, if we stuck to the same units, then we'd have something that looks very flat, because we saw with our units here, they are actually in meters. So if they were in millimeters, the difference between 56 and 58 is 2 millimeters thereabouts, which is not going to give us much of a sight. So what we can do is change those units to meters here, and when we just OK that, we will end up with all the points raised in space. Incidentally, the Show Me will take you to videos showing you exactly how to do that, and that is in common with a number of tools within the Caddie program there, designed to show you a quick way to expand your knowledge. So we'll OK that, and we'll just drag our rectangle, as it says select the entities there, so we'll drag to select the entities, and there we see our site, or all the points for the site, raised in space. Of course that's very good, but it doesn't give us anything in the way of something that we can section and so on. So for that we need a tin model. So here we'll move back to the DTM tools, and we'll choose a triangulate. Drag over our new points, and we see that what we have now is a mesh created, a tin mesh. So joins the triangles, and here we have the ability to swap the triangles, for instance. So if we decide that it's better to change the way the triangles are joined, and if we look at this in maybe a font shaded with wireframe there, that will be easier to see. So we could say, well, that's not the optimum for these particular triangles, move them around, get them to exactly how we want them to be. And what I'm going to do here is simply copy the tin model and we'll just copy it there, and then go back to the plan view, and then give ourselves a copy of the page, because what I'd like to do is have something to reference the changes that we make against. So here, if we're looking, for instance, to maybe re-level the site, we can do that. But before we do that, let's just take a section through. So we can take a section through here, and it doesn't need to be a single straight section. We can actually perform crank sections too. So option end that, having put in our points, we can put in our text height, we can put in a reference level. So here we see the minimum section heights and the maximum section heights there through the area we've drawn. We can draw those section lines on the plan as well. OK, that, and there is our site section. So we see we have a pronounced rise within the body of the site. So if we decide to do some leveling on there, and here we can do that. So we'll take in an area here, option end, and height. So the minimum height of the object is 50 meters, and the maximum is 59. So if we took that up to say 58, we can put in whatever figure we like. We're going to retriangulate the outline to give us a much closer outline to the edge that we performed, rather than just extending the triangles that we already have. OK to that, and there we see that we have indeed changed the look of our site quite dramatically. So we can see that plateau in there. And of course, going back to our section, which is now incorrect, we can update that. So we can update the section, and here we have the options for changing any of the things that we originally indicated when we drew the section. OK that, and we can see that we now have the change in the levels reflected. If we had this and we were thinking of doing some cut and fill, say at the bottom end, and we wanted to make sure that we didn't have any further soil to be removed, or spoil to be removed from site, or maybe to be brought onto the site, then we can use the cut and fill here, and we can pick the type of soil that we're into, which will change the bulking factor there. We can indicate the number of passes, because this is an iterative process, and you'll see you've got the mouse overs on entry boxes there in the dialog. OK to that, and again we choose the area that we wish, option end, and Caddie will do the passes. This is the difference between the spoil off and the material on. So yes to that if we're OK with that, and again we can see that we now have a change in the level, so we've got a terracing effect there. And if we just update that section once more, then there we'll see that reflected in the section. And of course we can do multiple sections through the site equally easily. One final thing on this portion of the webinar, what we're going to do is just look at the volume differences. So we'll do a quick calculation on that, or Caddie will do that for us. So here we can simply drag our selection box around the first model, and then do a similar exercise around the second one, option ending, and Caddie will give us a readout in cubic meters for the difference between the two sites. In this exercise, we'll explore how we can read information direct from files. So Excel files, XLSX files, maybe just text files, where we'll read it in and interpret the formatting, so whether it's commas or spaces and so on. Caddie will allow us to do that. We can literally bring that information straight in, plotting it within our drawings, and then taking it on to create 3D tin models. We can actually colour those tin models by gradient, so we can explore maybe which areas of our site are best for development, or maybe potential problem or opportunity areas. And then we can also introduce contours, so actually create contours fully labelled up on our drawings, again direct from the tools we have within Caddie. So let's explore that firstly by bringing in using our survey application here, so the survey application and then survey 2. So we'll load in from file coordinates here, and we see we have text files, DAT files, XLSX files. We're going to go for a DAT file here, so just loading that information in, and you see we have different separators for the formatting, space, tabs, comma, and other, and we can assign which values are which from the columns that we have. So column 1 will be the X value, column 2 Y, and column Z, choosing the tick box there to make it column 3. And we can have extra fields there for putting text on and point numbers and so on. So we OK that. Caddie will actually then load all of that information into the drawing, plotting it so we can take a look at our 3D site model. Having read the points in, we can orbit around our drawing, and we can see that we have rather a lot of points within this particular drawing. That gives us some idea of the nature of the site. We can create a 3D tin model from that using again the DTM tools. So going into DTM, creating our DTM literally by just dragging around the objects that we have, and by layering the drawing we can turn off the points, for instance. We can also just use our scope selector there, so if we just turn off our points, we'll see that we now have the 3D tin model. We can explore the possibilities, the opportunities, and maybe the problems of the site in a little more depth by colour coding all of the triangles. We don't have to do this manually. We have a tool here which allows us to colour code all of the DTM polyface mesh triangles that we have by virtue of their gradient. So you can see here anything that's between 0 and 3 degrees, we're going to colour code blue, and moving right on up through shades of green there to purple and a purpley pink there at the highest gradients. And we can do this for just a particular area or for the entire drawing, as we'll do here. So we'll say OK to that, and we see Caddie will start to introduce those colours to the site, and we can see it building up, so the steeper gradients are being calculated there, getting right on through to the steepest gradients, which gives us a much better idea of how the site is in terms of gradient. And we can look at that again with a different render view. So if we go for Fong Shaded, for instance, now we can see very much more clearly the nature of the landscape that we have at our disposal. And taking this, we can also explore the possibilities for producing contours here, because we might want to actually issue a drawing or prepare a drawing with those contours to describe the site in more depth in that respect. So if we go for contours, and you see again we select the entities, we just drag a simple rectangle around, we can layer our drawing to make sure that it's very easy to section off particular aspects of the information that we have. We can choose the minimum and the maximum contour heights and the major contours and the contour intervals there, through to the pen colours that we're going to use, and whether we want polylines or splines. So splines will be the smoother, polylines more angular. We can also put text labels on there, so we can govern the size of the height of the text, and whether it's inclined to the horizontal or aligned with the contours themselves. OK to that, and Caddie will carry out the calculations, producing all of the contours there, and we'll take a look at that in just a second. So you'll see then just how many contours Caddie has actually prepared, simply by clicking the tool within the DTM application. And here we see all of the contours and around the lake at the bottom there. And if we go to the top view, we'll see that we have a drawing which would have taken an inordinately long time to draft manually. In this example, we'll explore how, having generated a 3D tin model from a collection of point height data, a 5-meter grid for instance, we can then take multiple cross sections at a single stroke using the X-section tool within Caddie, placing them on our drawing. How we can also map images instead of onto the 3D tin model onto a smooth polyface mesh created from that 3D tin model. Here we've imported the ProMap site mapping data, so our site plan if you like. We can also take on board the height points, so here on a regular grid, so we can either have the DSM or DTM, digital surface or digital terrain model. Then using our triangulation tool within the DTM application, what we can do is convert all of those points, or all of the ones that we want to, simply by dragging an enclosing rectangle around them, into a 3D tin. So having generated the 3D tin in the same way that we did in previous examples, what we can do is now look at how we can derive site sections through here. So just taking a section line there, it's a polyline, and we can introduce these site sections simply using the X section tool. So pick on the X section and it says indicate the polyline for the profile, so we can zoom in onto this and we can see our polyline there. It asks us for the section intervals, the section width, vertical scale multiplier, we can include a reference level there which we'll do as well, and we have the text height because we can annotate the sections at the same time. OK to that, and Caddie asks us where we'd like to place them, so we simply indicate on our drawing and Caddie will create all of those sections in a single hit. So what we see here is that Caddie has created the multiple site sections for us, complete with the annotations, and then on our plan it's included the lines showing where the sections were actually taken along the polyline path that we chose. And if we just choose to turn off the 3D tin, okay, we can see that path all the way along the road. Returning to our 3D tin model, what we can do is if we just turn the tin model on its own, there's our tin model. What we can do is we can merge all of those separate objects into a single polyface mesh, or if there are too many nodes within that polyface mesh because there's a finite limit to the amount allowable under .dwg, Caddie will actually create multiple meshes for you in a single operation. So we can merge the DTM into a single polyface mesh and simply again drag our rectangle around. And here we see that Caddie's automatically created 2 polyface meshes from our 3D tin model. Now, in order to drape an aerial photograph onto our model that we have here, first of all what we need to do is secure that aerial photograph. So we're going to do that. I'll go into another drawing here. We're going to do it through the survey tools, survey 2, and through our coordinate load. So I'm going to load the last coordinates there simply to save a little bit of time, but just doing a quick Google search, you see we have the north and west coordinates there for our particular site. So just enter those in there. You'll notice that the longitude is minus because it's west rather than east, and Caddie will convert it automatically. We simply choose which particular setup we're using here. So we've got Google Earth, Microsoft Virtual Earth, which we're going to use here, and Caddie will automatically fill in the rest. You can do custom ones too. We can output that file, so we'll just plot that and then we'll just close down. When we go to MSAT, we can insert world template, and we can see there that there's our site. Click in there and the tiles are downloaded. We can zoom in further and MSAT again, it will download new tiles, and you see as we get further and further in, we get to a position where we have tiles that we want. So there we are. But these are all individual tiles. Now we can merge those into a single image, and just whilst we're having a look, if we go to settings and drawing settings, you'll see that for the pictures we can show the boundaries are not or not, so we'll just turn them off and then just do a quick regen, and so those disappear then. But these are still individual images. Just whilst we have the images, if we're wanting to measure anything, we have the latitude and longitude, we can measure things. So if we wanted to know roughly how far that was from the junction there, you can see that it will give us the distance, and you can choose the configuration that you're in, whether you want it in kilometres, miles, and just do a recalc, and it will recalculate that for you. So that is actually measuring straight from the images that have come in from Google Earth, Microsoft Virtual Earth. But we can also write on the drawing. You see we have the ability to write on the drawing, put in a dialogue or a command line, the latitude and longitude, and we can choose the format or the configuration there as well. So this gives us the ability to literally just pick our positions, and we can see it updating on the cursor. But back to our merging of the images, that's where we go to the Caddie menu, the main Caddie menu, advanced objects, and then we'll just choose merge images. So we grab the images that we wish to take. This will allow us to save the image, and here's one that I saved earlier, which can then be imported back into our main drawing, which we would do just through the files menu and insert picture. So insert picture, it takes us to the dialogue. We just select it there, open the picture, and pick a position in our drawing to place the image. Then to drape the image onto our polyface meshes, we go back to the DTM menu and use the drape tool, and all we do here is indicate two reference points on our image. So it'll be two known points that we see there that we can reference on our polyface mesh model. I've done this already just to save a little bit of time, and we'll see the result here when I change the render mode to Phong shaded. So there it is mapped, and as we rotate we can see that we have that image mapped onto our polyface meshes. And Caddie will also allow you to map the image onto multiple polyface meshes too, so you get a nice seamless join between them. In this example, we'll explore how we can use the 3D models available from people like ProMap and ZMapping to incorporate our own designs into, creating 3D walkthroughs, sun and shadow studies, and giving ourselves a much better idea of how our development will look within the built-up environment locally. We'll start by taking a constrained orbit around our site. So here we can just swing around, changing our viewpoint to get a good idea of where we're actually going to be developing. And in the centre here we've got a site. We might want to add an additional unit onto here, maybe taking down a couple of trees. So let's see how we can achieve that. So we'll start by just calling up one of the saved views. So I'll go for the site plan here. And there we are, we have a plan view of our site. And we'll see that the areas come in, they're very nicely layered. And this one's on a layer called grass. If we're thinking of changing this to parking, we can do that simply by changing it to the layer allocated for parking, which will change its properties there. And the trees, we'll take those away simply by selecting them and deleting them. Now if we had the same unit, we could just simply copy that around, but we're going to bring in as an externally referenced symbol, so an xref, so we'll bring that in. and you'll see that we can bring it in as an attachment or an overlay. We're going to go with attachment here, and we've got pathing options there too, and we just bring it in and place it down onto our site. And there's our building. Now, we might want to just play around with the positioning, in which case we can select it, rotate it, and we can do this dynamically, literally just picking and swinging the building around. But we might also want to position it with respect to a boundary, for instance. So here we can use the construction lines within Caddie, and drop the construction line in there, we'll drop another one in here, and we could do offsets, so 3.5 meters, for instance, from there, and then the building is 9.5 meters wide, so we know that, say, this point here needs to go onto this corner here for it to fit between those tram lines. So we'll select our building, and we can move it into its new location, choosing snap modes that are appropriate. And so now we can simply rotate our building, right click, rotate, 0 is dynamic for the dynamic rotate, and we'll just rotate around our point here, our second point here, and then just lock it onto the construction line. And then of course we can delete the construction lines. Rotating our model up, quick regen gives us the buildings in place. And if we don't need the wireframe, we can simply turn it to foam. So there's our model in place. Now we can take additional cars and so on. So just selecting them and then copying them, placing them within our model. We can create walkthroughs. So adding a walkthrough path, which is a spline. These can be created just by going to 3D views, setting up for a walkthrough. So we set up major camera positions and number of intermediate camera points, so we get a nice smooth transition between. We can export those to slides as well if we wished, and then group those together, build them together into an SWF file. You see here we have the slide size as well. So we can take a look at where our cameras are positioned at the moment, and we can see we have our procession of cameras through the site, and if we wish we can change the orientation of our cameras, change the height, and literally just swing them around so we can choose wherever they might be. Going to a 3D perspective rather than axonometric, we can also walk through our site. So we see we're actually taking a look down our chosen path. And here we can link all the individual slides into a single SWF movie, which can then be passed on to clients and so on for them to have a look at, even if they don't have a copy of Caddie. So we'll just run through the walkthrough there. So this one is unrendered, so this is just the model as they are. There is the possibility though of using the photorealistic rendering with Caddie View to provide the same thing actually rendered with full materials. And when it comes to working out things like overshadowing and so on, we can use the shadow plots facilities within Caddie View, setting up exactly where our building is within the world, in the city or town, using latitude or longitude, its orientation, where north is, and choosing the scheme that we wish to use as well. So there are night schemes there as well as daytime schemes. So that there we can set the conditions for our renders. We can actually render it at particular times throughout the day, choosing our viewpoint. And Caddie will even notify us by email when the study is completed. So if we have a live study, and here it's playing the SWF file that created to link them all together. The SWF creation utility within Caddie creating this for us, and then just going to another view. I'll just take a look inside our site in perspective mode rather than axonometric, and we could create our own render. Now we've got progressive rendering or the linear rendering there. We could determine the quality as well, and choosing things like enabling advanced finishes. So we'll just do a very quick render here in progressive mode. OK to that, and we'll see the render develop on our screen. And now we have the option to save the image, which we could then pass on to the client either by email or even posting on a website. So using Caddie and the wealth of information that's available to us, we can create accurate 3D visualizations to support our proposals, showing the 3D models of our designs actually located within street scenes, on landscapes, and just helping to add weight to any applications that we put forward.